Hello, everybody. Hope you're doing great this morning. Just a quick little review of our unit and try to get us prepared for next week as we pull this all together. I do want to remind you also of the Rube Goldberg project, and hopefully we're making progress where that lies. So, our unit energy, work, and power. We started out by learning about some different forms of energy. Learned about thermal energy, the motion of the particles that just at the atomic level. Chemical energy is stored in those chemical bonds, and when we break those bonds, we can release some of that energy. And then we went into mechanical energy, which is actually the one that we spent the most of our time with, dealing with kinetic and potential energy. Specifically for us, it was widely in the terms of gravitational potential energy. Um, Electromagnetic energy, that was where we had waves uh, that would travel and transmit energy through space. Electrical energy, the positive and negative charges, we'll spend lots more time with that in our next unit. And then nuclear energy with fission and fusion uh, and breaking apart the nucleus of atomic nuclei. Um, in that, we also learned that energy is conserved. In other words, the total amount stays the same. We can't create or destroy it, but it will change forms, and it will take on different forms in all kinds of different situations. We have, in this example, we got the nuclear fusion happening in the sun, which transmits through light and heat and other radiation to the earth. Plants use that to produce food, and which we can then eventually can turn into fossil fuels or stored chemical energy in their chemical bonds. We can burn that in engines and turn it into thermal and mechanical energy, and so forth. And the process continues. Lots of changing of forms of energy, but the total amount stays the same. We learned about simple machines, 6 in particular. The inclined plane, the lever, the wedge, screw, pulley, wheel, and axle. All different types of simple machines that can give us what we call a mechanical advantage. And hopefully we were able to put that into practice with our Rube Goldberg machines. The levers, again, you've got a fulcrum and a solid arm that will rigid bar that's pivoted around that fulcrum, kind of like a seesaw or scissors will have that. The inclined plane is going to reduce the input force by increasing the distance that is moved. Okay, and that will help us in a number of different circumstances in the inclined plane. The screw is basically a cylinder that's got an inclined plane wrapped around it. Right? And that, of course, is a real important tool in a lot of construction that we do. Pulleys can give us a mechanical advantage by using a rope that fits in the groove of a wheel, all right, and supporting those ropes, and you can, with the input and output force, can be changed. A wedge can take an input force and move it in different directions, all right, and make that output force spread out. The wheel and axle, of course, well, we use wheels all the time, but that will allow the thinner radius to turn the same as the wider radius, and what you can do then is increase your output force with a smaller input force. And we use these things. Here's a lever that jacking up a car. All right, they make work easier sometimes by, we can increase the input force in a car jack. We can change the direction of the force, okay, or change the distance of the force that it acts on. All right, and the idea then is to gain a mechanical advantage, make it easier for us. And so that mechanical advantage is going to be the number of times the machine multiplies our input force. Right? If we get 300 newtons out of the job with only putting 100 newtons in, we have a 3-to-1 ratio, or 3-to-1 mechanical advantage. We're never going to be able to have a perfect scenario. We'll always lose a little bit of energy due to friction in the process, but hopefully the idea is that we want to make it as efficient as possible. So here's just a little page summarizing some of those things. Energy then, when it's transferred, we say work is being done. Work is going to be a transfer of that energy. Energy is the ability to do that. And here you see a weightlifter making work happen because it's moving a force over a distance. Work is equal to force times distance. We measure both in joules. Primarily, we've been focused upon kinetic and potential energy. Kinetic energy is the energy of motion. Got that formula 1/2 mv squared. Okay, so the more mass or more velocity it has, the more kinetic energy it will have. Okay, we got some calculations that we can do in the process and so forth. Gravitational potential energy depends on the mass, gravity, and the height. Again, the height that something has, the more energy it's got, more gravitational potential energy it'll have. Likewise, okay, how much mass it has and how much gravity is pulling on it is going to make a big difference. Here on Earth, that acceleration due to gravity, of course, is 9.8 meters per second squared. So we've got energy, the ability to make a change. Work is a transfer of energy. Kinetic energy is motion. Potential energy is a stored energy. Primarily, we focus again gravitational potential energy based on the mass, height, and the gravity. Okay. Work is done when the motion happens in the direction of the force. Again, we got that formula. Work is equal to force times the distance. Okay. And we went through some of the problem solving. Again, it's a little tricky. Remember, the motion has to be in the direction of the force in order for work to be done. We went through some examples of that as well. And then power is going to be how fast can we get that work done. To increase power, we got to increase the work we'll increase the work that's done in a given time, or do the same amount of time work in less time. We got another formula. Power is equal to work divided by time. And power is going to be measured in watts. Good luck with finishing up your assignments, and there will be a little practice test for you. And we look forward to seeing you soon.